Okay, so we shall move further. So this is the one program where we can print odd numbers by using for loop. So what you people will do is like in the you can write the sentence in this way. So in the previous program, if we change from I plus plus to I is equals to 2, so you can look at this program. So rest everything is same. Say in for loop, in for I is equals to 1, I less than or equals to n, I instead of I plus plus you have to write I equals to I plus 2 with pencil within the bracket. You can write it in the same program, or after the program and tracing what you have written in the previous program. After that program and tracing and also after output, you can write this one line. So for I is equals to 1, I less than or equals to n, I equals to I plus 2. Instead of I plus plus, you have to write I equals to I plus 2. So we have the option to write in the same line itself. That is I is equals to I plus 2. Okay, you can write in this way. So if you write I equals to I plus 2, it prints odd numbers. You can just copy the output. So enter the value of n, 10. The odd numbers from 1 to 10 are 1, 3, 5, 7, 9. So in case of even numbers, the initial value you have to change it to I is equals to 2. That's all. So the remaining thing is same. Okay. So in sentences, you can write it. I plus plus prints the numbers in sequence, that is 1, 2, 3, 4 and so on. I equals to I plus 2 with initial value I equals to 1 prints odd numbers. I equals to I plus 2 with initial value I equals to 2 prints even numbers. So in the notepad I will write it. You can note down so that when you execute the program, so you can test these things. Okay. See this for loop, like I is equals to 1, I less than or equals to n, I plus plus. Okay. So this prints numbers 1, 2, 3 and so on. Okay, in sequence. Okay, then for so I is equals to 1. So I in the declaration part you can just declare the variable and leave it. That is int I. So in the for loop only you can write I equals to 1. So I is equals to I plus 2. So this prints odd numbers. So printf is same. Printf %d backslash t I, that is same. So this prints odd numbers. So then for so I is equals to 2, I less than or equals to n. So I is equals to I plus 2. So you just observe the difference between the second for loop statement I have written and third one. So in the second I have taken I equals to 1 and I equals to I plus 2. In the third I have taken I equals to 2. Initial value itself is 2, so that it prints even numbers. If you start from odd number, it prints odd numbers. If you start from even number, it prints even numbers. So this you can take down. So at least you take down this. In when you execute the programs, you can test these things. So you take down these three things. I will wait. Okay. So I hope you people have understood about the looping statements. We come at the end of the looping statements, while, do while, and for. So we saw the differences between while loop and do while loop, and we saw some three programs in while loop and do while loop, even in for loop. So three similar programs. That is, whatever the programs we saw in while loop, same programs in do while and even in for loop. Because the way we write differs, and when we go to the arrays chapter, you will come to know the exact application of this for loop. So why for loop is good when compared to while loop and do while loop in writing the program. Okay. And also it executes fast compared to while loop and do while loop, because here everything in one line it is present: initialization, condition, and increment or decrement step. Okay. And we have one more type of looping, that is nested loop. So after this jump or unconditional branching statements, we can look into the nested looping concept. Okay. So now we will move to the uh, jump or unconditional branching statements. So which is the third category in third category in control statements. Okay. So first category is selection or conditional statements. Second category is looping statements or looping, or we can call it as iteration. Third one is jump or unconditional branching statements. So these are called as branching statements. Okay. Because when you look at the flow chart, you will come to know why these are called as branching statements. See, one flow chart I will show you. See here. So it's look like branches only, like arrow mark. If you look at the arrow mark, execution path. Sometimes we change the path, we follow the path. So these are the branching statements. And two types of branching are conditional and unconditional. Okay. So even while loop also we can call it as branching, but it's better to call looping or iteration. Okay, here. So in case of branching, that is conditional and unconditional, statements are executed only once, not more than once. In case of looping, statements can execute one or more than once. Okay. So here,
Your voice is breaking.
okay. So signal is proper, sir. Here signal is showing full. It's not a problem. I am observing the router. There is nothing wrong in signal, and I have put earphones too.
No, no. Once or twice it's happening, but now it just has it, and the latency with respect to the screen that you're sharing is still existing. I'm not sure if that is true or facing the same.
Okay.
Yeah. While you were explaining jump or unconditional branching statement, I think you were showing some flowchart or anything, and
Yes, yes,
it came up with late.
yes. I just compared it. I wanted to compare. So I showed it, and again I came
Yeah,
to.
but that came up late. After you explained, the page came up.
Oh, okay, fine. Now I think it's looking jumper or unconditional.
While you while you were explaining, you were at this page, the one which is now giving a explanation about jump or unconditional branching statement, right?
Okay, okay,
So
fine.
if you were in this page, but what you were explaining, I believe it was another page.
Okay, fine. I think it's looking now jumper unconditional.
Yeah, that is the when
Okay.
I'm able to look at that. It's a word pad, a word document,
Document.
and
Yes.
it's the explanation.
Yes, yes. Okay. So here the definition says the process of transfer of program control from one part of the program to another part unconditionally. The word this is very important. That means when we transfer the program control from one part of the program to another part, so it depends on condition, and it depends on looping. In looping also we write the condition, but here when it comes to jump or unconditional, so if we don't write condition also, program control will be transferred from one part of the program to another part. So it is called as unconditionally. So it is called unconditional branching. The statements or keywords used for this process are unconditional branching statements. Is it okay, sir? Is still a problem?
No, this is fine. Yeah.
Okay, okay, fine. So once again, we will see. So there are two things: conditional branching and unconditional branching. In case of conditional branching, so program control will transfer from one part of the program to another part by looking at the condition. That is depends on the condition. In case of unconditional, there is a process of transfer of program control from one part of the another part unconditionally. That means here we don't require any condition, but still the program control will be transferred. So if this happens, we write the condition just to stop that thing because it executes infinite number of times if it transfers in that way. So we stop the transfer of program control by writing the condition. That doesn't mean that these statements require condition. Okay, in the example we'll come to know. So the statements used for this purpose are jump or unconditional branching statements. The keywords break, continue, go to, and return. These are the four keywords which we use for unconditional statements. And there is one more word, exit. Exit is a function. It is not a keyword. It is inbuilt function, library function. So here I have not written. Here I have mentioned only keywords: break, continue, go to, and return. So now we will move to the go to statement. Okay, the name itself tells go to. So go to means the program control should move from one part of the program to another part. Okay, so the go to is a keyword used to transfer program control from one part of the program to another part unconditionally. Same definition we can consider. Okay, that is in general for the unconditional branching statements. The same thing we can consider for go to statements. So go to is a keyword used to transfer program control from one part of the program to another part unconditionally. So here we will see the syntax of go to. So in many ways we can write. So generally authors will write one way. That means in in some other ways we can try it in the editor part. So here I have written three ways of using go to. So this is one way. So how we can write? Okay, so this is the first form. So first we have to write the label. Okay, so in front of label colon symbol is required. So you just observe here. So first we have to write the label, then in front of label we have to write the colon symbol. In front of colon we should start writing the statements. So statement 1 to n. Okay, so just I put dot dot. So statement 1 to n we have to write the statements. After that we have to use the go to keyword. After go to, one space you have to leave, then you have to write the label. Okay, so here go to is a keyword. uh, Statements are normal C language statements, valid statements. Label is an identifier. You just observe here, label is an identifier. So again we have. Srinivas sir, I am hearing your voice.
Sorry.
I am hearing your voice. I don't know, some disturbance in between.
Okay. No, no. My okay. No, no, I had unmuted, and suddenly, the other thing
Okay,
started ringing.
fine.
Yeah, I was just moving around.
Okay, fine.
I'll go on mute.
Okay, so here in the first form, if you observe, label, it is an identifier. So again, we have come across the concept of identifier. So here you have to remember the rules of identifiers. Okay, that is first character should not be a digit. Blank spaces are not allowed. Keywords are not allowed. And symbols only underscore is allowed, and that is not compulsory. If we want to use the symbol, we have to use underscore. That's all. So in this way, we have to remember the rules of identifier. So once you remember the rules of identifier, then you can write the label part. Okay, label is an identifier. So for example, here, label is a general word. If I write A, B, C, 1, 2, 3, you just check the rules of identifiers. Cap letters are allowed, small letters are allowed, digits are allowed, but not at the first place. Blank space is not allowed. symbols except underscore is not allowed, keywords are not allowed. So this particular identifier, it is following all the rules of identifier. So ABC123 is perfect identifier, that is valid identifier. Same identifier we have to use here because it is general word label. So ABC123 is a label, that label I am using here. Okay. Okay. Next, in the second form, so the way we write it changes. Functionality is same. The way we write is it changes. So if you observe the second form, see if you observe the difference, in the first form I have written label colon statement 1 to n go to label. In the second form, first only I have written go to label, then label colon statement 1 to n. Okay. So we will see in the example, we will see how it works. Okay. Then coming to the third part. Okay. Okay, if you observe the third one, go to label. See, after the statement go to label, some statements we can write, some valid C language statements. After that, you can write the label colon, then statement 1 to statement n. Okay. So wherever you write label colon statement 1 to n, so that indicates that we can consider it as like one block. Okay. So these are the three forms. You just copy the definition and go to definition. So later you can copy the syntax. Okay.